Hey there, welcome to the lab. Today we're going to have a look at what's in this box. It should be a Brymen 2257 multimeter. It's proving to be a fairly popular meter. A little bit of time for me to get it because it was sold out a lot of places. And there have been a couple of requests from viewers to have a look at this meter, so that's why I thought I'd get this. Now, I did get this unit with my own funds, so I just want to mention that if you found this video to be helpful, please give it a thumbs up and subscribe to my channel. Questions and comments are always welcome, and the feedback is really appreciated. It helps me figure out where to focus my activity, this being an example. So let's get into the box. Now, I ordered this from TME in Poland because Brymen doesn't sell under the Brymen name in North America. They sell rebranded products. And I also decided to go with the Brymen unit as opposed to going with the EEV Blog Blue unit. So this came from TME, and so I have here in the box, TME is fantastic with shipping. I've got the multimeter. They put it in an anti-static bag. It's a little bit of an overkill, but we'll take it. And also, I did get the USB interface for data logging, so we'll have a look at how data logging works as well. So, kind of have a two-part unboxing, I guess. So here's the Brymen unit. So we can see that this is the 2250 series. 2257, 2251. This should be a 2257. It says that right there on the box. Good. And so we open that up, and there is a set of batteries. Okay, that's good to know. And the unit itself. And one of the things that is special about this unit is the compact size. So this is fairly compact. Let's compare that to the other meter that I'm going to be looking at in this video, which is, well, comparing it to, which is the Fluke 117. So it's actually even smaller than the Fluke 117. So it's shorter and it's about the same width. It does feel a little more compact in the hand. So I don't have exact measurements, but it feels like a very compact unit. And we'll be looking at all of those things in a minute. Put that down. We've got here now, also in the box. Okay, so there's some instructions. In Polish, of course, but also in English. That's good. And I expect that this manual is all in English. Yeah. Perfect. Brymen has some decent manuals. So that's everything in the box. Now let's have a look at these probes. Oh. Okay. So got some probes, and each one is kind of wrapped separately. Now these they feel like silicone. So these feel like the sort of standard Brymen silicone probes, although there's no lettering on them. The flex and the feel to them feels like silicone. And of course they're gold tipped, gold plated, and they have this feature where the sort of the barrel that can make it fit into a banana jack screws off. So that's nice. This kind of makes it for a two-in-one kind of probe. The shrouds, of course, for high voltage scenarios are separate. They don't come shipped on top because, of course, these little pieces would get in the way. So you got to take that off, and then that snaps on, and you got that. So I generally am using them like this without the little banana cover or barrel connector, whatever you want to call that. So good set of probes. And like I said, these seem to be the standard Brymen silicone probes. And the Brymen thermocouple with the sort of plug here that's designed for temperature sensing, as opposed to having two separate probes. There's the one, or two separate plugs. There's the one plug there. So that is everything that's in the box. The other thing that we want to have a look at is this USB kit for data logging. So this for this unit, this is a model BRUA20X for the BM250 series. Okay, so the box does multiple duty. So we have in here so that's sort of an optical coupler that will fit in the slot at the back here. And there's a ferrite bead there that can run all over the place, and that goes to old school DB9 connector. So this is probably, well, it's RS-232. Then you get a USB-A to USB, I think that's USB-B connector. Then because that's RS-232, you get a little RS-232 to USB converter. So, and then there's a CD. I'll have to find a computer with a CD on it to read the CD. And that's everything in that box. So a lot of stuff for data logging. I guess there probably are still some units out there that connect with RS-232, and so in order to, I guess, make this a little bit more universal or flexible, Brymen is kind of going the extra mile, so to speak, by having the RS-232 cable and then this serial to USB adapter to convert from the RS-232 signals to USB. So that's kind of nice of them. Now, back to the batteries. In order to get the batteries in, there's a screw here. Now we have to take the overmold off. Now, one of the things that's interesting is that this piece, the stand, is actually attached into the overmold as opposed to attached to this unit. So once the overmold is off, well, you can't use the stand anymore, but I guess that's okay, because honestly, I'm never going to use the unit like that. So let's just look at getting that battery out and getting the cover out and getting the batteries in there. So I've loosened the screw. That cover comes off. Fortunately, the screw doesn't just fall out. Now it's nice here to see that we can access the fuses. So the fuse for what I expect is the 10 amp range, is here. So it's an 11 amp fuse like usual. And then there's a 630 milliamp fuse here for the other range. And so it says 0.6 amps. So a little bit of wiggle room there, which is nice to see. A lot of vendors put a 600 milliamp fuse in there. So the second you go over, you're kind of frying the fuse. And spot for the two AAA batteries. So we'll put those in a second. And then there's a couple of other screws here. I wonder if we can take those screws off and have a little bit of a teardown. Let's try that before we get into this. So not too bad. There's 3 screws that need to come out in order to get the back cover off. And so now we can see here, now it's going to be a challenge to see very much because there's this other board covering it. And I'm a little bit reluctant to pry the other board off. So we can see here, we can see a couple of mauves there that'll give us some surge protection. We can see the current shunt there. And there's not a lot that we can see on this side of the board. Well, you know what they say, in for a penny, in for a pound. Let's see if we can have a look at the other side of the board. All right, well, if you're tearing the unit down for yourself, a couple of things to notice. There are screws, there's underneath the fuse sockets, underneath the fuses, so there's a screw there, and there's another screw there that have to come out. And then the unit comes out quite easily, so that's good to know. Now, on this side of the board, you can see that everything really, all the intelligence here is in that module there. And I'll see if I can figure out the model number on that. Then we can see the contact area, the sockets for the test leads, the standard stuff there, and not too much else. I mean, we can see the contact points for the buttons and such. Let's see if I can get the number off of the main chip here. We can see the contact strip along the top for the LCD. There are some power pads for the LCD as well here, and they're spring loaded. So if you look at the LCD unit itself, you can see it's got a couple of springs to power the LCD display. So we've got the two batteries in there, and just so I don't forget to mention it, at least there's a threaded screw here. None of the other screws that I had to remove during the teardown are threaded. That's not surprising. You wouldn't be getting into there that often. So I'll just put this back on, and this screw goes in quite easily. And now I'm just going to put the overmold back on, and then we'll try to power it up and see if it still works after the teardown. Always something that I worry about when I do those sorts of things, you know. But I will say there was no sign that said no user serviceable parts inside, so I guess it was fair game. So got the overmold on, and now let's try to power it up and see if it all works. So there's power. So we've got a nice clear display that you can see there, and we can turn on the backlight by holding this button down, and we've got the nice backlight there, a little bit of an amber cast to it, and apparently that backlight will stay on for about 16 minutes or so when there's no activity on the meter, and we can turn it off just like that. By default, this unit doesn't make any sounds as we're changing between the modes. So that's something to be aware of if you're used to units that tend to make a lot of noise. So during the video, I plan to compare the BM2257 mainly against the Fluke 117, but in some cases I'm going to bring in the big brother of the 2257, let's say the BM789, in order to kind of be a tiebreaker or an adjudicator. And that's what I'm doing here for DC voltage. So I've got a voltage reference source here, and the reference, the calibrated reference values will be in the overlay. Now let's turn all of these on to DC voltage. So we've got DC voltage across the board, And good thing they're all reading 0 because it's not turned on yet. So now let's turn on the voltage source. And I should start out. So this is the tops. This is 10 volts. And we can see that the Fluke and the Brymen are showing 10 volts. The 789 is showing just a touch under 10 volts. And you can see the reference source is a little bit over 10 volts. Now, at 7.5 volts, we see that the 789 is closer. The 2257 and the 117 are both reading 7.5 volts dead on. At 5 volts, we should be a little bit above 5. The 2257 is a little bit below 5. And the Fluke is 5 dead on. The 789 is just a bit above 5, closer to where it should be. And then at 2.5 volts, we've got the Fluke at 2.5 dead on. The 2257 is a little bit below where it should be. The 789 is showing 2.5 volts dead on. So, good showing for the 2257. But all of these meters are fantastic meters overall. Now for AC volts, I've got it plugged in or connected to the mains here. Now the power is not on, and so we're seeing ghost voltage across all of these. Not too surprising. Now I'm going to turn the power on, and these are all in the dedicated AC voltage mode. So we can see the voltage there. I'm going to turn the power off and on again. We can see that they're all pretty quick. The Brymen 2257 might be a touch faster, but they all perform very well. Now we can get the frequency for all of them here. So if we hold that down, 60 hertz there on the Fluke, hold that down, and on the 789. So we can see that the frequency, they're all showing pretty close to the same frequency, the 789 and the Fluke kind of showing 60.02 or 01 depending upon the rounding, and the 2257 generally showing closer to 60 hertz dead on. So now let's look at the 3 meters in the low Z mode. And so that provides a high impedance pathway in the meter to try to eliminate the ghost voltages. So right now they're all showing either auto in the case of the 2 Brymens or 0 in terms of the Fluke. And the power is off, and so that's more or less what we would expect. So there's no voltage there at the moment. Now I'm going to turn the power on and pay attention to the amount of time it takes for each of these to show a voltage reading in this mode. So I think the Fluke was a little faster there than the 789 and then the 2257. We'll do it one more time. So the 789 and the Fluke seem to be a little comparable that time. Once again, the 2257, a little bit of lag in the low Z mode in order to come up with the voltage. Now we're going to have a look at resistance. We're going to use this reference source with the calibrated measured values in the overlay. One thing to note with the Brymen here is that resistance, diode check, capacitance, and continuity are all on the same mode, and we choose using the select button. One of the features of the Brymen is that if, for example, if I'm in continuity and I turn the meter off and I turn it back on again, it remembers that I was in continuity mode. So I don't have to always kind of go through the process of reselecting the mode every time I turn the unit off. Now we want to be in resistance here. So that's resistance. So let's measure these, and I'll call them out as I'm measuring them. So this first one, that's 10 ohms. That's 100 ohms. 1000 ohms or 1K. 10K. And 100K. And so good showing from the Brymen there. All of the values are indeed a little bit below the called out value. Now let's have a look at the Fluke. In order to eliminate the impact of the probes, I'll use the same probes here. The Fluke has a dedicated mode for, or a dedicated spot, if you will, on the dial for resistance, and I'll just go through these again quickly. That's 10 ohms, 100 ohms, 1K, 10K, and 100K. And so the Brymen did a little bit better than the Fluke on that resistance pass. Now we're going to look at capacitance, and the first capacitor here is sometimes tricky because it's 100 picofarads. So let's start there. So that's 100 picofarads, and so that's not registering. Well, there we go. So that's showing up on the Fluke. That's showing up on the Brymen as 0.13 nanofarads. Now we'll go to 1 nanofarad, 10 nanofarads, 100 nanofarads, 1000 nanofarads, and 10 microfarads. So that's the Brymen. Now over to the Fluke. Get to capacitance mode. So same as before. 100 picofarads. So the Fluke's not really showing much of anything there. 1 nanofarad. Ten nanofarads. 100 nanofarads. 1000 nanofarads. And 10 microfarads. So a little bit of a tough call to say whether one is more consistent than the other. The Brymen was able to measure the 100 picofarad capacitor, but in general some measurements were better with the Brymen, some measurements were better with the Fluke, really varying depending upon which particular capacitor we were measuring. Now for diode check, we've got a test box here, a couple of diodes here at the top, then a bunch of LEDs and a short. So the idea is to see how the unit behaves during diode check mode. So for the good measurement there, good measurement there. So the Brymen's able to light up all of the LEDs, and for the valid diodes we've got the little short beep, and for the short we've got the constant beep and the light goes off. So one of the things that I look for in diode check is the beep mode, and the Fluke behaves in exactly the same way. So short beep, diodes all light up, and a constant from the Fluke. But the one difference is the light doesn't go off on the Fluke, whereas on the Brymen the backlight lights up. But otherwise, similar behavior. Now for continuity, I just do this tapping test. And we can see that the Brymen reacts extremely quickly, doesn't really miss a beat. No worries there. And the Fluke has equally good performance for continuity. In fact, I might even say that the Brymen seems to perform a little bit better there, just because there seems to be a hint of lag. Even though the Fluke gets every tap, there's a touch of lag, whereas with the Brymen, no lag at all. So fantastic performance from the Brymen in continuity mode, picking up very short taps. And the other thing is that the backlight also comes on, even though it might be for a split second on those taps. So great performance from the Brymen in continuity. Now we're going to have a look at DC amps, and in a way milliamps as well. Now with the Brymen, there's a very cool feature. If I try to go into voltage mode, but I have the probes plugged into the amp range, or the milliamp range, I get a warning, an error, saying, hey, don't measure voltage in amp mode. That's a good way to blow the fuse, or blow the meter, depending upon whether it's a good meter or not. So if I'm plugged in there, and I go to amp mode, of course, that's where I'm supposed to be. And the Brymen determines whether it's in amp mode or milliamp mode, depending upon where the probe is placed. So here it's amp mode, and when the probe goes there, it's in milliamp mode. We'll have a look at both. I have a little test circuit here with the breadboard. It's going to feed 5 volts through a 150 ohm resistor. And if we do our math with Ohm's law, we should get 33 milliamps, 0.033 amps. Now if I turn the power on with the Brymen, I'm seeing about 32 milliamps, 0.032 amps. That's fairly typical. There might be a little more resistance between the leads and stuff like that, taking me a little bit away from the ideal measurement of 33 milliamps. If I switch the Brymen over now to the milliamp range, we can see we've got a little more accuracy there. So I've got 32.25 milliamps, so even closer, if you will, to the ideal value. Now we can take that over to the Fluke. The Fluke only does amps, it doesn't do milliamps. So the Fluke varies a little bit between 32 and 33 milliamps. And it's a little bit tough to tell whether that's a result of the impact of the leads, or whether the Fluke is a little more accurate. Now in terms of non-contact voltage, my general approach is to take this plug and bring it to where the non-contact sensor is for these meters. Now on the Fluke, in general, it seems that the sensor is right at the front, and I think for the Brymen the sensors at the front as well, and the hot line runs along this edge of the plug, this being the ground and that being the neutral. So this is where the hot line is. So if we bring this close to the Brymen, you can see that it reacts pretty well, telling us that there's some voltage out here. The Fluke also reacts pretty well at that distance, telling us that there's some voltage. And of course, with the Brymen, we get a little bit of a field strength indicator. The Fluke just says yes or no. And so with the Brymen, when we get it right to the wherever the sensor is, but in general, I would expect the sensor to be around the middle, the Brymen shows us the strength of the field. So I will give that one to the Brymen. Now, both of these have a sort of a sensitivity level, so the Fluke can go into low sensitivity, and the Brymen can also go into low sensitivity. And in low sensitivity, which I'm not a fan of, you can see the Brymen is picking up something out here. And the Fluke also is picking up something out here. So, whereas before they would both pick up something out there. So, I'm not a fan of the low sensitivity mode. I generally prefer to use the high sensitivity unless I'm in a very noisy environment. But I have to say that I am happy with the performance of the Brymen. It's one of the few, other than the Fluke has always been fantastic in this regard, but the Brymen is one of the few that actually also functions in terms of this mode. A lot of other multimeters have a non-contact voltage that doesn't really function very well at all. The Brymen has a hot wire detection feature. The Fluke does not have a hot wire detection feature. Now, one of the things to notice, so I've got this cord again, and oops, recall this is the hot side. One of the things that happens is that this line turns into a little bit of an antenna, if you will, and so it'll sort of trigger, out here. It can trigger the detection. So, although it seems that I'm having a little bit of, yeah, you can see that this sometimes will trigger, sometimes won't. So in general, the recommendation is to go into the low sensitivity range, and then we don't see as much noise in this mode. Oh, well, maybe we do. And then if we hit the ground, no reaction, neutral, no reaction, but the hot wire tells us that it's active. So that's how the hot wire feature works on the Brymen. And once again, the Fluke doesn't have a mode like that. Now, for temperature measurement, the Brymen has this thermocouple probe, and it's got a nice plug. I prefer this over the ones where the two ends are just sort of flopping around on their own. One thing to notice is that one of the sides of the plug is coated with a red dot, so that's the one that has to go in to the positive terminal here. Now we'll just move this to the temperature range, which is also the millivolt range. We'll plug that in and switch that to temperature. So there we see a temperature in Celsius. We can also get Fahrenheit. It is kind of cool down here. I'll use my hands, my fingertips to warm this up, and it reacts very quickly. And we can see I can usually get this to about 31 Celsius if my hands are warm. There we go. So the temperature probe works very well and very sensitive, and the Fluke doesn't have a temperature mode available. So it's nice to see just how quick and responsive the temperature measurement is. And in case you're really curious, well, there's a Fahrenheit mode, but the thermocouple puts out a millivolt value, and as the sort of temperature rises, the millivolt level increases. So right now, as it's cooling off, you can see that it's dropping down. If I touch it, you can see that the millivolt level rises quite rapidly. And so there's some internal calibration where it knows what millivolt level to use for corresponds to a certain temperature. So that's how the temperature measurement works. Now, just for kicks, I thought, well, the Fluke doesn't have a temperature rating level, but it does have a millivolt range. And so I said, well, here's the thermocouple. I've plugged it in. And so without me touching it, it's showing 0.1 millivolts. So close to what the Brymen was showing. Now down to 0. If I touch it, this should go up to 0.5, maybe up to 0.6. There we go. So in that sense, there's an interesting correlation in terms of the millivolts. Even though it's not calibrated, we can see that we're getting about the same number of millivolts on the Fluke that we got on the Brymen when we put them into the millivolt range or millivolt mode and use the thermocouple here. The meter has a few other features that I will go into fairly quickly. And so there's a hold feature that can be used to hold the reading. So when I remove the lead there, the reading stays present. And there's an auto hold feature. And the idea of the auto hold feature is that I don't have to press the hold button for it to hold into a reading. So if I hold that down, you see AH begins to flash there. And I'm going to change the reading there. And now if I take my probe away, you can see it's stored that value. And if I put the probe back, and if the voltage goes higher, and I take the probe away, it remembers that. So it remembers the value that locks in, and that works in a few of the modes, not just voltage. So you don't have to manually press the hold button in order to lock in a reading. So that auto hold is kind of neat. There's also a relative feature, so you can do something like zero out the resistance of some probes if you have some probes with too high a resistance. There is a min-max averaging feature, so I'm just going to leave the auto hold here, turn that off. So I press that, and we see max min average there. And so if I connect that, it'll tell me by pressing this the max voltage, the min voltage. You can see that it was ranging because it wasn't connected the whole time. And then the average voltage, and the average voltage will range because it's the average, it's a cumulative average from the time in which you first entered the min-max average mode. There's a crest feature, and the idea with the crest feature is it will sample very rapidly and it'll show over the time period in which crest is active, it'll show the maximum or the minimum in that time period. So we're hooked up to that reference source. If I press that, you can see that there was a momentary peak there, very rapid, up to 10.04 volts. That's saying C max. If I press that again, we can see the C min. So that fell down to 9.95 volts. And it'll just keep switching back and forth between max and min. And it is kind of checking the whole time. See that had a little bit of a change there. The maximum peaked up to 10.05 volts. So that's what the crest feature does. Kind of handy if you're trying to catch some sort of a really quick transient and see exactly where something peaks or valleys out in a certain measurement. The meter has a data logging mode. Now, before I show you how the data logging software works, a couple of things to note. So first off, we've got this serial cable to USB. I'm not showing you the USB cord, but there's this optocoupler, and the optocoupler, in case you're wondering, goes into the back of the unit, and the way you can tell how it fits is because there's a notch here on one side of the molding in order to accommodate the way the cable is designed here. So if we just slide that in like so and give it a little bit of a press, that fits in like that. So now that's connected in a sense, and when to go into data logging mode, we have to hold down the hold button. Think they'd put something there to indicate that, but they don't. So we hold down the hold button and turn it on, and when we do that, there's a little COM indication that appears in the bottom left corner, COM, and so that means that the data logging or the connectivity is activated on the meter side. And then of course you have to do all the rest of the rigmarole on the Windows side in order to get the connection going. What you're seeing right now is the screen for what Brymen calls the data logging system. And so the Universal Data Logging System CD comes with installers for, I think, every meter that Brymen makes that has a data logging capability. And you can then, there's a little bit of a front end there where you can indicate which meter you have, and it will install the software that corresponds to that meter. Now, getting the meter connected is a little bit tricky at the beginning, but it seems to work reliably once it's connected. So when I first plugged in the USB cord, Windows told me that it was connected to COM3, and so I went into this port dialog, which I can't change at the moment, so I'm going to unlink. So I went into this port dialog, and I chose COM3 as the communication port that I was going to use, and OK. And then once you've specified the port to connect to the meter, you have to specify, go through what they call link to the DMM. So I'm going to do that. Now it's hard to tell that I'm linked. I'm just going to go into a mode that generates a little bit of noise. There's the AC mode. And so as I change modes, you can see on the display, which is mirroring the display reasonably, the different modes that I'm in. So AC voltage, I go to DC voltage, I can go to that's resistance, and I can select, and that's diode check, although what it shows is V, but that is the diode check mode. Then this is capacitance. This is, yes, I think that's resistance again. This is continuity. And so you can see that maybe there's a little bit of information that is lacking in terms of the display because it's not telling me that it's continuity mode, although maybe you don't really want a data log continuity, not very clear. So there's the display up here, which mirrors the display on the meter to some degree. Then there's an analog meter display here. Now, of course, it's showing over range because we're in continuity mode and it's an open circuit. And then there's a list here which will be populated with values, and then there's a data logging graph here. So most of these windows have very little in the way of controls. You can move them around, but there's not much of a point in moving them around. It wants the application, if you move them around like so, it wants to have them in a certain spot, and you can do that by clicking this button called Window Tile, and it'll just restore them into this standard default organization. Now, what I'm going to do in order to show some of the data logging capabilities, I'm going to go into DC volts, and I've got a voltage reference source. I'm not sure what voltage it's set to. There we go. So that's 10 volts on the DC voltage reference source, and I'm going to start the logging here by clicking on this button called Acquisition Start. And so it's going to start reading values in, and you can see the graph over here. And so this is 10 volts. Now, for some reason, the analog meter, they've decided to do this as a range going from 0 to 6. So this could be done in any way possible, but for whatever reason, I guess because the meter is a 6,000 count meter, they've decided to do that as 0 to 6. And that creates a little bit of a weird set of properties, because when I go to 2.5 volts, this now, instead of being a times 10 there, becomes 2.5. And so that makes sense. And then 5 volts, okay, that makes sense. And then for 7.5 volts, this becomes 0.75 and then times 10. So it's a little bit weird that they've done the reading that way. And this keeps logging. Now, this is logging at what the user interface, if we just stop the acquisition for a second, and there's a interval option here. That was what's called full speed, and so the speed doesn't seem that rapid. Other meters that I've had data logging can go faster. We can try to customize this, but it says input an integer value, anything less than 1. So if you try to enter 0.25, for example, that won't work. So the best you can do here is a 1 second interval or full speed. So we'll just leave this for now at full speed. And then there are options here for saving the logging to a file, throwing away the logging session, and moving through the pages. So if you do get the meter, I mean, the logging, what can I tell you? The logging works, and you can export this logging list that's here on the left side. This can be exported to a comma separated value file, and then you can read that in with Excel or any other application you might want to use. Overall, when you look at this, this application, given the fact that it says it's compatible with Windows 98, this application looks like it was written 20 years ago and hasn't really been updated, except for maybe a little bit of compatibility since that time. And so compared to other applications, compared to what you might expect as an application on the Windows or the Mac platform, although this only runs on the Windows platform, but compared to applications that you might expect these days, this looks really super primitive and extremely clunky, I've got to say. I think it's a real sore point to have such a fantastic meter with such a poor data logging system. Now, you probably don't need anything too fancy, but just the general usability of this is frustrating, to say the least. It works, but it is frustrating to use this interface. One of the things that I want to mention beforehand is that there is a manual logging capability. So if I put it in manual, I can click on this button here, manual acquisition, and every time I click on it, you can see the points building in the lower left here. Every time I click on that, it acquires a point. And so if I change the reading there, in summary, this Brymen is a really fantastic meter. It's got more functionality than the Fluke 117. It's got more features. It's seemingly a little bit more accurate. It's compact, basically about the same size. There is nothing that I really can complain about in this meter as the unit itself. I will say, though, that the one negative around this meter is the data logging. So the data logging software, as you saw, that is available for this meter is extremely primitive. But data logging aside, this is a fantastic meter with extremely, extremely good accuracy, a ton of capabilities, more features and functions than the comparably sized Fluke 117. So I think for this particular head-to-head, the Brymen BM2257 wins this head-to-head hands down.